Good morning students, welcome to the GPREC Center for Digital Education. Today in our e-content development program, I am going to be discuss a topic in concrete technology, that is lecture number 2, Cement Part 2. Okay, in the previous e-content development program that we have discussed the same topic, cement, that is part 1. We have discussed introduction of cement, types of cement and manufacturing process of cement. Okay, now we are going to discuss the remaining topics will be mentioned in this cement material. Okay, that is next. The next topic is hydration. What is mean by the hydration? How the hydration wall occurs in the cement paste? Okay, so when in the previous e-content only that I have told, cement is available only in powder. Okay, not as a cement paste. If it is available in the cement paste, slowly it will turns into the hardened shape. So when it turns into the hardened shape, it will set. After setting, it won't be work as any condition. Slowly it increases its strength. So in our marketing places, the cement will be purchased as a the cement will be available as a powder form. Okay, in this cement powder, I am going to be adding the water. Why we have to add the water? Because to generate the binding nature, to generate the binding to generate the binding strength in cement. Why we have to generate the binding strength in cement? Because this it will be used for concrete members, not concrete beams, concrete members. Okay, in that concrete members, it will become concrete beams, concrete columns, concrete slabs and concrete flyovers, bridges, anything. So here we have to be focus one point. So in this cement powder, if I'm going to be adding the water, okay, slowly it generates the binding nature. How, when coming to the binding nature, how it is how it is generating this binding nature? So in this one, there are having some of the research concepts in this binding nature. So the hydration, hydrated cements, chemical compositions were presented. Okay, now we will discuss some this content very deeply in this lecture. Okay, see what is mean by the hydration. Hydrated cement, it refers to the cement that has chemically reacted with the water. This reaction is called the hydration process. Okay, see here, the hydrated cement or hydration of a cement, it refers where cement is added with the water or mixed with the water. Okay, where cement is mixed with the water, it will be reactions will be generated. Those reactions are chemically reactions. So here the hydration process will be start. So the hydrated cement refers to the cement that has chemically reacted with the water. This reaction is called as a hydration process. So what it will be happens after hydration process? Nothing but it is what makes the cement, it turns into the harden and slowly it gains the strength to form as a concrete member. Now the students, you people have understood, no, cement it is available in the powder form. In that cement I will be add the water. How, what it will be happen? Cement paste it will be happen. But we have to question in our mind where the binding is coming, how it is going to be hardening, where the strength is coming from this cement material, because the main hydration process. So that's why I have divided the two parts in this e-content development program of lecture number 2. Okay, done. Now again I will be discuss here with you. Finally done. So the hydration is a nothing but it is defined as a which refers to the cement that has chemically reacted with the water. This is called the hydration process. So often in the hydration process only the cement it becomes the cement it makes as a hardened and slowly it gains the strength to form in the concrete member. You people can observe here how the hydration process will be how. So in this cement material the water I am going to be adding. So in this chemical reaction process we are observing what is CSH, calcium silicate hydroxides, next calcium oxides. These are the hydration products. So how it is going to be generating? Why? Because when the manufacturing process of a cement there will be having some of the chemicals where the chemicals are coming from the calcareous materials and the argillaceous materials. So these chemicals will be reacted with the water, it will be generating some other type of chemicals. So the other type of chemicals it only generates the binding nature, strength of a cement and setting time of a cement. So how the different types of cements was prepared because of this hydration process. Here some types of chemical some types of chemical compositions were presented. Okay, done. What happens during the hydration process? Nothing but see here. For example, when water is added to the cement, okay, when water is added to the cement, first thing chemical reactions starts immediately. Okay, next new compounds will be formed very like first one is CSH. CSH is nothing but calcium silicate hydrate. When the CSH is formed in that cement paste, okay, you keep it as a very blindly, it gives a strength. Okay, just a strength. Okay, next again it forms the calcium oxide and also etringate and monosulfate type of materials it will be present, and these products it forms as a hard and stones like mass. It is a hydrated cement. This is a hydrated cement. So automatically in the cement powder when we are going to be adding the water it starts the binding, but how the strength will come means because of this two types of chemically reacted compounds will be found. So this is the concept is nothing but the hydration. Then what is mean by the heat of hydration? So same the heat of hydration concept is somewhat interlinking in this hydration. What is mean by the hydration? Okay, in the cement powder I'm going to be adding the water, there will be having a chemical reaction, there chemical reaction with the water. Slowly the cement hardens and gains the strength. Coming to the hydrated of cement or else cement heat of hydration. The heat of hydration is nothing but the amount of heat released when water reacts with the cement during the hydration process. See how much very depth concept is there. See when manufacturing process of the cement material we will collect some calcareous materials, argillaceous materials. However we are adding that gypsum powder. Slowly that cement material is not a natural source of a material, it is a entirely artificial source of a material presented with a number of chemicals. Okay, in that chemical cement I'm going to be adding the water. Two types of a two common types of a word terminology we are finding. One is hydration process, another one is the heat of hydration process. Heat of hydration and hydration process we can look here when the water is added in the cement. If it is reacting with the chemical reaction means that is the hydration process. If the heat is releasing from the cement paste, how much heat it is releasing or the amount of heat is released when the water reacts with the cement during the hydration process, that is heat of hydration process we can say. So this heat of hydration process is an exothermic reaction, meaning it generates the heat process. Okay, next. chemical composition. Okay, just now we have discussed, when the water is added into the cement, there will be having the chemical reaction. In this chemical reaction, there are will be formed chemical compositions. Chemicals means availability of chemicals. Compositions means the composition. There are having different or two or three or more chemicals will be formed as a one compound. That is CSH, like that, CAH, like that. Okay, the next concept is chemical composition of cement. So this chemical composition of cement, it is having the extension process of hydration of process. So cement mainly it contains four major oxides and three minor oxides. Okay, so the four major oxides are: one is lime, second one is the silica, third one is the alumina, and fourth one is the iron oxide. There is a chemical formula for these type of oxides. For lime, what is the chemical formula? CaO. So CaO. Okay, if you observe these image here, major oxides, chemical formula, percentages, functions. See, in the cement, for example, in the cement material, if lime is available, what is the formula of a chemical formula of a lime? That is CaO. How much percentage it is available? 60 to 67 percentage. And this lime material, in which type of raw material it will become under, means calcareous material. Okay, see, the lime is presented in the cement material, that is 60 to 67 percentage. What is its function? It generates the strength and soundness. Okay, next, silica. Silica is nothing but chemical formula SiO2. Percentage is available 17 to 25 percentage. So it also generates strength property. So from the CSH is calcium silicate hydrated. When this chemical composition was formed in the reacted with the water, that is hydration process. Okay, next, same like that as minor oxides, there are having the three minor oxides. One is magnesia, sulfur trioxide, and alkalis. Okay, so the chemical formulas of magnesia is MgO, sulfur trioxide is SO3, and alkalis Na2O and K2O. Nothing but sodiums, or else any potassiums, this will be come under the alkalis. So the percentage of magnesia is presented if 0.1 to 4 percentage. Too much causes expansion, and the sulfur trioxide it will be present, that is 1 to 3 percentage. It controls the setting. Nothing but this sulfur trioxide is presented in the gypsum. Next, alkalis, if it is presented in the cement material, that is 0.2 to 1 percentage, it can causes efflorescence. Okay, so you people can observe here one of a small image, chemical composition of cement, that is minor oxides and major oxides. So in this entire oxides, lime it will be available. Why? Because lime is a calcareous material. So from that one only we will get, that binding nature. Okay, next, again in this chemical composition of a cement, there are having some of the four different types of chemical compositions. It was invented by the Box person. So we are going to be calling as a Box compound. So the percentage of Box compounds in cement can be varied to change the properties of the cement. So this determines strength, setting time, and heat of hydration process. Okay, next, what are those Box compound? One is C3S, nothing but tricalcium silicate. Second one, C2S, dicalcium silicate. Third one, C3A, tricalcium aluminate. And fourth one, tetracalcium aluminoferrate, that is C4AF. The another name, so there will be having a very short name for these types of Box compound. For C3S it will be called as alite. For C2S it will be called as belite. And for C3A it will be called as cellite. And for C4AF it will be called as pellite. Okay, allied, balate, phthalate, salate. Sorry, allied, balate, salate, phthalate. Okay, the chemical composition of a box compound, the C3 is nothing but tricalcium tricalcium silicate. The chemical formula is tri means 3. Okay, C3S is going to be presented as, what is the calcium formula? CaO. Okay, silicate formula SiO2. So how many calciums it was presented? Nothing but 3. So 3 CaO SiO2. Same as it is. If I am going to be providing C2S, nothing but I am going to be present 2 CaO SiO2. If I am going to be providing C3A, that is tricalcium aluminate. So what is the tricalcium aluminate? Nothing but the calcium formula is CaO. Aluminate formula is Al2O3. So how many calciums are presented? 3. So 3 CaO Al2O3. Same like that as C4AF. Nothing but 4 calciums CaO. Next alumino Al2O3 ferrite Fe2O3. So these are the different chemical compositions have been found after in the formation of a hydration process. It was invented by the person, he is Box person. Okay, done. Sir, what it will be happen, sir, if these chemical compositions were presented in that cement material? How much percentage? Nothing but, if the C3S, if it contains 40 to 60 percentage, nothing but it gives the early strength and heat of hydration. Next, if C2S, dicalcium silicate, it is presented 15 to 30 percentage, it will provides the latter strength. Okay, next, the C3A, tricalcium aluminate. So if it is present 3 to 10 percentage in cement, there will be having a fast reaction and very high heat. Okay, and coming to the C4AF, that is 4 CaO, Al2O3 and Fe2O3, that is 6 to 10 percentage. It will be used in the moderates, heat and colors. Okay, these are the chemical compositions of cement. Now coming to the types of cements, types of testing of cements. Okay, done. So this type of testings of cement is one of a major important task for every manufacturer companies. Why? Because in the industries, they will be prepare some different types of cements. Whether the quality of a cement is having a good or wrong, we have to be however, after manufacturing process, we will be sent to the marketing places. From that marketing places, all the customers, they will purchase and use for the construction purpose. If it was any damage was happened for the construction, to whom that words will become? Okay, so that's why we have to be conduct some types of specific small types of test for the cement material. Okay, so after the having the manufacturing process, before the dispatching that cement material, we will conduct types of testings. Okay, see, these types of testing, types of cement, it will be formed in two types. One is field test, another one is laboratory test. Okay, field test means, for example, if you have purchased one cement bag, okay, that cement bag will be tested in field itself. Okay, so nothing but the cement will test only in field, nothing but construction site areas. What we will be test? First one, if we observe the cement bag, so what is the type of a cement, whether it is OPC or PPC. Okay, if we observe the cement bag, we will be observed if it is OPC, what type of a grade it is, whether it is 33 grade, 43 grade, 53 grade, or else what is the manufacture, best before the 3 months or 4 months, and mostly best before the 3 months. Next, slowly the types of the test will be conducted in field, we will be discussed. And next, coming to the laboratory test, nothing but the cement bags, sorry, the industry persons who have manufactured the cement material, they will be sent one bag for the consultancy officers or else consultancy test laboratories. So that cement will be tested only in laboratory. There are having some type of depth types of testing. What are the types of test? Size of a test. Okay, so size, next setting time, what is the standard consistencies, okay, what is the water percentage it will be available, and next what is the strength of a cement. Okay, these are the types of the testings will be available in this cement material. Okay, now we will see the field test on the cements, nothing but it will be conducted on site locations, nothing but in the construction sites. So there are having different, these are the types. So before going to these conducting types, if you have purchased cement, the first type you have to be refer from the cement bag, that is type of a cement you have to be observed, whether it is PPC or OPC. If it is PPC means, okay, directly go for the manufacturing process. If it is OPC, what is the type of a grade? That is grade 33, grade 43, grade 53. Okay, if it is not OPC cement means, if it confirms it is a PPC means, directly you can go what is the manufacture date of cement and expire date of cement. Okay, if it confirms as a PPC, sorry, if it is confirms as a OPC cement, then you have to check whether it is 33 grade, whether it is 43 grade, whether it is 53 grade. Okay, then we have to be refer the code book of OPC, that is IS 269 cement grade. For the OPC, we will prefer IS 269. There are having different code books available for the different types of cements. In that one, for the OPC, we can refer, IS 269. Okay, done. So these are the types of testing we have to be checked in the field areas. Later we will move. First one is colored test. So you people observe here in this image, the cement, it should be look as a uniform gray color. It should not be look as black. It should not be look as greenish color. Okay, most of the cements, it should be look like as a uniform gray color. If it is turning into the black color means slowly it is reducing the manufacturing process. Next, lumps test. Lumps test means cements should be free from lumps. How we will be check? Just keep keep our hand into that in the cement. You just collect some cement. In that cement powder, any lumps will be have been formed. These are the lumps. See how solid particles of a lump, solid particles of a lumps, if it is having means it indicates no, if it is lumps are provided in the cement means it indicates there is a some percentage of moisture absorption is presented. If there is free from lumps, there is a no moisture absorption have been presented. Next, field test. So when we have collected the cement in our hand, it should be feel as very smooth and silky, not gritty. Okay, next, temperature test. So next, temperature test. So in that cement bag, just keep our hand up to the down and slowly rotate. Okay, your hand it should be feel as very cool, not the warm. Okay, our hand it should be feel as cool after dipping into that cement bag. Next one, float test. Take some small quantity of cement and thrown onto the water, so it should be float for some time before sinking. This is the field test of floating test of cement. Just collect one bucket of water. In that water, just collect some quantity of cement and throw in that one water which is storage in the bucket. So what it will be happen, the cement it should be float on the water sometime. After that, slowly it can sink. So that is the types of field testing will be conducted. Okay, next, laboratory test. There are having different laboratory tests. It will be conducted only in laboratory places. Those types are fineness cement, consistency cement, setting time cement. Okay, first one, what is mean by the fineness cement? Fineness means nothing but we can find the size of a cement. So what is the cement size? Nothing but 90 microns sieve is the size. The size of a cement is 90 microns. Size of a cement is 90 microns. See, very small particle, it will be look like as a powder form. So the fineness cement, it will be conducted in laboratory. The kind of apparatus we need, one is weighing balance, second one is the trowel, third one is the brush, and fourth one is the sieve. Nothing but 90 microns sieve. Okay, it measures the particle size of a cement. It is also called as sieve test conducting for the cement material to determine what is the size of a cement. Okay, after conducting the cement, we will get result. From that result, as per IS 269, from the result, if if the passing of it should be maintained less than 90 percentage of cement should be passed, or else less than 10% of cement should be retained. What is this passing? What is should be retained? Let us take a small sieve. This is a small sieve. I am taking 100 grams of cement and placing in this sieve. After having the some kind of shaking process, here the 90 percentage of cement should be passing from these sieves. What is mean by retained? Retained means nothing but less than 10 percentage of cement is retained on the sieves. Okay, so that's why we have to take 90 microns of sieve. Okay, next, consistency test. Okay, next, consistency test. The consistency test, it is going to be find out nothing but to find the water content value. Okay, the kind of a apparatus we will be used in that is Vicat apparatus. The apparatus name is Vicat apparatus. Actually, Vicat is one of a human person. He have invented this type of apparatus to conduct the consistency test. In that consistency test, we will be conduct one is standard consistency test of a cement and setting time of a cement. Okay, so in that consistency test, we will use Vicat apparatus, stopwatch and gauging tools and mold, glass plate, plungers. Okay, same Vicat apparatus I will be used for the setting time of a cement. Okay, now we will be discuss here consistency type of a test. So it will be performed using the Vicat apparatus to find standard consistency. Usually the p value it should be referred as 26 percentage to 33 percentage. Okay, next, coming to the setting time. So when we got the p value that is 32 percentage, these 32 percentage will be carry forward to preparation of a cement paste. Okay, how much quantity of a water we have to be add means the quantity of water, it is referred from the standard consistency test. Okay, that quantity of water will be taken and calculate. After the calculation, we will prepare the cement paste and we will move for the latter tests. Okay, so in that one, first one is the setting time. In this setting, there are having two types of setting time of cement. One is initial setting time, another one is the final setting time. See here, now take the cement and add the water, which is 32%, it was mentioned. For that one, 0.85 into P for one type of a test, 0.75 into P another type of a test. Next, P by 4 plus P by 4 plus 3 into cement plus sand, it will be adding of water, it will become under the another test, that is a strength test. Okay, for initial setting time, just 0.85 into P. P is nothing but 32 percentage I got. 0.85 into P, I will calculate. I will get the water quantity. So add that water quantity into that cement. So prepare the cement paste. So that cement paste will be placed in that mold. Okay, that cement paste will be placed in that mold. So after placing, before placing the mold, first set the glass plate. Okay, so on that glass plate itself, keep that mold and fill the cement paste. Okay, so slowly shake that slowly shake this mold. Why? Because if there is any small little bit air voids, it will be there, means slowly it will be get set. Okay, so fully we have to be apply that cement paste in this mold. So later, if you are going to be conducting initial setting time, you have to be wait minimum 30 minutes. For final setting time, you have to be wait for 600 minutes, nothing but 10 hours of time. Okay, now you have prepared the cement paste and you kept into this mold and slowly take this mold to the vicat apparatus, but don't use the plunger. So there will be needle, a small needle will be available. For the initial setting time, the needle is used. Okay, two types of needle will be provided. So the one of a needle will be used for the initial setting time and another needle, it will be provided as like this. Some small point will be there. It will be used for the final setting time. And this is a plunger. It will be used for standard consistency test. Sir, what we will be do means this needle we will be placed here. So here the needle will be placed. Okay, so here at side any screw will be provided. If we remove that screw, slowly, this is the stem, slowly it will be penetrate into this mold. Okay, so when we have to be conduct means the cement paste is prepared and placed in this and placed in this mold. Okay, after the 30 minutes you have to be conduct the initial setting time, nothing but after the 30 minutes what it will be happen, how much after the 30 minutes, how much the cement takes time to set as a hard. Okay, so that is rapid hardening cement that we are going to be discussed no in the previous lecture video. So the time management we will be observed by conducting the setting time of this test. So at initial at the initial time, at a final time, how much time it takes means, so in the initial setting time we will be wait for the 30 minutes. After the 30 minutes we will be release this needle slowly that needle it will be penetrate like that triangle part we have to be collect. Okay, so at 30 minutes after, how much time it takes to turn into the hardened shape. Next, final setting time it comes, we have to be wait patiently after the 10 hours, nothing but 600 minutes. After the 10 hours we have to be place that mold and slowly and change this needle, provide this needle and slowly release that stem, slowly it will get penetrate. after the 30 after the 600 minutes, how much sorry how much after the 600 minutes, how much hardened it becomes. Okay, see, like this we will be conduct. Okay, same apparatus, VCAT apparatus. For the standard consistency test, I have placed here plunger. For the initial setting time and final setting time, see, for the final setting time, the needle you observe. Okay, see, in the initial setting time, after the 30 minutes also it is there in the cement is in wet state. Okay, 10 hours means it will turns into hardened shape. Okay, in that hardened shape also it will be get little bit some kind of a penetration. So for that one purpose we will use the other type of a needle. Okay, so it determines how fast cement starts and completes the hardening process. Okay, yeah. Next, the few more laboratory types of cement is that is soundness test. So the type of for the soundness test, it ensures the cement does not undergo the excessive expansion. So the apparatus we are going to be available in the laboratories, that is Lee Chatellier's apparatus. Okay, Lee Chatellier's apparatus, nothing but autoclave test also we can provide it. Nothing but there will be available a small cylinder and one of a split cylinder, and arms, two arms will be provided. The initial length of a the initial length of these two the initial length of a two arms are having less than 100 mm. Okay, after preparation of a cement paste, okay, after preparation of a cement paste, we will be check the expansion of a cement. Okay, so for the excessive expansion purpose we will conduct this soundness test. So it will turns into the hardened, no, so due to the weathering conditions it will be having some kind of expansion. So after having a small expansion, these two indicator arms also will get expand. So it should be less than 10 mm. It should not be expansion, it should be provided as less than 10 mm. The equipments we need, one is Lee Chatellier's apparatus with two arms and two glass plates and one of a loading stone. Okay, next one, compressive strength test. This is one of a important type of a test will be conducted in laboratories, nothing but to check the kind of a strength, how much strength it can bear the cement material. So to conduct this test, we will take the sand mortar ratio is 1:3. 1 is considered as a unit of cement and 3 is considered as a 3 parts of sand. Okay, if you are going to be adding the aggregate, then it will be coming into the concrete. But what I am conducting here, the type of a test, cements. So for the cement I will be take 1:3 is the standard. 1 is 1 part of cement, 3 is 3 parts of sand. Okay, so after that one, P by 4 plus 3 percentage, and for 1 plus 3. For example, 1 part means if you collected 1 kg of cement, so how many kgs of sand have to be take? Nothing but for 1 kg of cement, nothing but 3 kgs of sand, like that have to be provided. So then the water will be added into that cement mortar, slowly prepare that cement mortar and placed into the specific molds, nothing but so 10 mm by 100 mm by 100 mm by 100 mm. Okay, nothing but 150 mm by, or else 150 mm by 150 mm. So best thing is 100 mm by 100 mm by 100 mm. 150 means it will become under the concrete. So after 24 hours remold that one. Okay, after the 24 hours, so open that remove that mold and take that cement block and place into the water and have a curing process. After the 3 days, after the 7 days, you just keep into this compression testing machine. Compression testing machine and check how much load it is bearing. From that load, what is the strength we are getting. Okay, next, that is the compressor strength test will be conducted on the cement material. Next, heat of hydration test. So it measures heat generated during the hydration using by the calorimeter. So this is the calorimeter. So at starting we have discussed hydration process, height of hydrated cement, how we will be check that one by using this calorimeters. So it is important for the mass concretings. Okay, and the last, there are having very few and small laboratory test. One is a specific gravity test. So for the specific gravity test, we will use the Lee Chatelier's principle. Sorry, Lee Chatelier's flask. Okay, and next funnel or else any kerosene. So sir, why sir we should not take the water? Means if the water is going to be adding in the cement material, slowly it will be changes the reaction, no? So when coming to the kerosene, it won't changes the reaction. So the specific gravity test is conducted with the cement by placing of a kerosene in this Lee Chatelier's flask. After the getting the results, those results it should be permitted, should be presented in this 3.10 to 3.15 limits. Okay, next, bulk density test. Sorry, bulk density test. So it determines weight per volume of cement. Next, chemical composition test. The chemical composition tests, it will be available as a chemical types of testing, which like it will be found magnesia and silicon dioxide, Al2O3, Fe2O3 and calcium oxides, and loss of ignition and lime saturation factors. It will be available, it will be found from that chemical composition test. And finally, tensile strength test. Mostly that tensile strength test, it won't be considered, but sometimes for the research purpose we will be conduct. So this is the older test, replaced by the compressor strength test, same as it is. Okay, same as it is. How the compression strength test is going to be conducting for this cement, means same like that one only. Tensile strength test will be conducted. It measures resistance to tension purpose. Okay, so these are the concepts we have discussed here. Thank you.